Lipid Catabolism by Taylor Hardman, Jasmine Moore, Sarah Crowther, Abby Hunter, and Brooke Morgan. Tag's journey.
This is Tag. She is the youngest in the triglyceride family. Say hi, Tag. Hello. The triglyceride family is formed from a simple 3-carbon alcohol known as glycerol, which allows for the attachment of 3 fatty acid chains. Fatty acids are chains of carbon and hydrogen molecules and can either be saturated or unsaturated. The fatty acid chains attach to the glycerol backbone via esterification. Due to the hydrophobic nature, the triglycerides can be stored compactly within the body. Today, Tag is very excited because she's about to embark on her greatest adventure. Are you ready, Tag? Sure am, let's go! For the first part of lipid digestion, mastication occurs. Tag, along with many others, live in foods such as pizza, oil, avocados, anywhere where lipids are present. Today, she lives on a delicious pizza. When a human comes along and eats the pizza, they chew, aka masticate, breaking the many molecules into fatty clumps ready to be transported. Tag, along with many other molecules such as carbohydrates and proteins, travel down the esophagus and into the stomach where gastric lipase is secreted and acts on the short-chain fatty acids. The fatty acid globules travel down the stomach and pass through a substance called chyme. As lipid-rich chyme leaves the stomach, it triggers the small intestine to release the hormone cholecystokinin, which stimulates the release of bile salts from the gallbladder and pancreatic lipase from the pancreas. Bile salts act as an emulsifier and break down large fat globules into smaller globules, increasing the surface area in which pancreatic lipase can act upon in further digestion. Pancreatic lipase proceeds to give Tag a makeover and breaks her down into her monoglyceride and fatty acid chain form. After pancreatic lipase activity, the monoglycerides and free fatty acid combine with bile salts and lecithin, a phospholipid from bile, to form small molecules such as micelles. Once inside the epithelial cells, monoglycerides and fatty acids enter the endoplasmic reticulum where they are resynthesized back into Tag's real form. Tags combined with cholesterol, phospholipids, and lecithin and coated with certain proteins to form water-soluble structures called chylomicrons. I feel so strong, ready to take on the world! The newly formed chylomicrons leave the mucosal cells through exocytosis and enter lymphatic vessels in the submucosa via lacteals. Tag then continues on her long and arduous journey to the thoracic duct, where they enter the bloodstream. A bright light on the chylomicron starts flashing. What's happening? That must be apoprotein C2. It's now activated and sending signals to lipoprotein lipase. Lipoprotein lipase is an enzyme that's found on the cells of capillary endothelium, and it's going to hydrolyze you and break you down into 3 fatty acids and glycerol. Get ready, Tag! Glycerol begins to move away. Where are you guys going? I'm going on another adventure, gluconeogenesis. I'm going to glycolysis. I'm going to be used for phospholipid synthesis or triacylglycerol synthesis. Not sure yet, but I will decide when I get there. They say their goodbyes and the glycerol make their own journey. However, the remaining fatty acids enter various cells to undergo beta oxidation and re-esterified for storage within the adipocytes. Tag is now in storage. Well, did we have fun today, Tag? I sure did, but I'm so tired. Good night. Tag goes to bed in the adipocyte. Good night, Tag. And so that concludes our adventure. We will see you next time when you eat a pizza or a cheeseburger or anything with fatty potential. Bye guys!